Hello everyone, welcome to EnggClasses YouTube channel. In this video we'll consider a numerical wherein x of k is given, which is 1j 1 minus j. Using the properties of DFT, it has been asked to find the DFTs of the following sequences. Is that okay? First, x of k is given, and its IDFT, that is x of n, is asked. But I cannot find x of n using the conventional way, making the formula using the formula of IDFT. It is not possible. What I have to make here is I have to make use of the properties. So that is important. Making use of properties of DFT, I need to find DFT of these sequences. So let's begin. First thing is I have to find this x1 of I'll just write to find x1 of n is equal to minus 1 to the power n x of n. The very first task is I need to identify which property I have to make use here. So that is the first and foremost thing to be done. So which property is that? A sequence x of n is getting multiplied with minus 1 to the power n, which is equal to multiplication by an exponential in time domain. So that is the property. I'll repeat, it is multiplication by an exponential in time domain, because the signal is in time domain and it is getting multiplied with an exponential. So that is the property, and it is also called as, very famously called as, frequency shift property. Is that okay? So the property here is frequency shift property. Before making use of frequency shift property, I have to convert this to an exponential. It's equivalent exponential. I just cannot consider minus 1 to the power n. So what is minus 1 to the power n? I'll write x1 of n is equal to minus 1 to the power n in terms of exponential can be written as e to the power j pi n into x of n. So this is the result, we must know it. So whenever we get minus 1 to the power n, it must be replaced with e to the power j pi n. So is that correct? So shall we cross check this one? So just do it for a few samples. Minus 1 to the power n is equal to, I said it is e to the power j pi n. So is that correct? Just check. Put n equal to 0. Anything to the power 0 is 1. We know it. Here also e to the power 0 will get, which is 1. So this is the value for n equal to 0. So now you put n equal to 1. Let's see what you get. If you put n equal to 1, it is minus 1 to the power 1, which is minus 1. Here it is e to the power j pi. What is e to the power j pi? It is cos pi plus j sin pi. Cos pi is minus 1. Sin pi is 0. So you will get minus 1. Similarly for n equal to 2. If you put n equal to 2 here, minus 1 square, which is plus 1. Are you getting it? So here also you put n equal to 2. It is e to the power j 2 pi. You will get it as cos 2 pi plus j sin 2 pi. Cos 2 pi is always 1. And sine 2 pi is 0. So in that way you'll get the result. Hence this result holds good. Are you getting it? So now I can proceed further. So what can I do now further? Ultimately what I want is, in terms of minus 1 to the power n, I want the twiddle factor. What is the twiddle factor? Twiddle factor is the wn. What is the expression for that? It is e to the power minus j 2 pi divided by capital N. So are we getting this here? We are almost there. We want exponential term e, it is there. Minus sign, it is not there, let it be. J, I want j is there. Then I want 2 pi. Is 2 pi available? No. Just multiply with the 2. Let's see. 2 pi divided by capital N. Capital N is, in our case, it is going to be 4, because x of k it has 4 samples. So capital N must be 4. So I have written it in this way. But I should not deviate from mathematics rules. I want e to the power j pi n. I have made the alterations and I got it 2 pi by 4. So if I divide it, it is actually 2 ones are 2 2 twos are. So I'll get e to the power j pi by 2, which is not there, 2 in the denominator. So I'll multiply that with the numerator. So everything will cancel out. I'll get ultimately e to the power j pi, which is there here. So multiply with n. Getting it? So into x of n. So what is this equal to? E to the power e to the power j 2 pi by n. This is nothing but twiddle factor wn. Are you getting it? This is wn. But we understand that it is minus. The minus sign must be there. As it is not there here, I'll include it here. So I'll get wn to the power minus 2n as it is, x of n. So now you look closely, this resembles, this looks like the formula, standard formula, multiplication by an exponential in time domain, or also known as frequency shift property. So I'll just write it, making use of frequency shift property, making use of frequency shift property, making use of frequency shift property. So what that property says? So property says that DFT of the property says that DFT of Wn to the power minus ln x of n is equal to x of k minus l. Is that okay? So now you compare. In place of wn we have it minus ln, we have minus 2n, x of n, x of n. So l must be 2. Just compare them. So l must be 2. So are we getting it? Therefore, so now I'll write dft of wn to the power minus 2n. This is what we want. X of n is equal to x of k minus l. In place of l we have 2. In place of capital N we have 4. Is that fine? Therefore ultimately x1 of k, this is what we are looking for, is equal to x of k minus 2. Is that okay? This is how we get x of k minus 2. But what is that equal to? X of k is been given, which is equal to 1j 1 minus j. I'll write that. We know that x of k is equal to 1 j 1 minus j. So this has been given. From this we want x of k minus 2. What is this x of k minus 2? It is circularly frequency shifted sequence. X of k minus 2 is nothing but circularly frequency shifted sequence. How do I shift that? Again, use the normal method. What is the shifting factor? It is 2. So what I have to do now? I'll consider the last two sequence samples and move them to the beginning. Are we getting it? X of k minus 2 is nothing but I'll consider the last two samples. I will move it to the beginning so that I'll get x of k minus 2. Suppose if it were x of k plus 2, in that case I would consider the first two samples and move them towards the end. That is the task. So that is not asked now. So whatever it is being asked, it is only x of k minus 2. I'll consider the last two samples, which are 1 minus j. I will move them to the beginning so that I'll get it something like this. So this is what the answer is. X of x1 of k is nothing but 1 minus j 1 j. Is that okay? So moving on further, I'll consider solving the next part B. So in the B they say, so I'll just go up and check. It says x2 of n is equal to x of n plus 1. So let's see that. Consider finding to find x2 of n is equal to x of n plus 1. So how do I find this? Are we getting it? So first try to find what is x of n plus 1. What is x of n plus 1? X of n plus 1 is nothing but circularly time shifted sequence. Is that okay? So I have to make use of circular time shift property. So that should come to the mind immediately. Is that okay? So before that, I'll just write the property. We know that. So what is that property? DFT of x of n minus m is equal to wn to the power k into m x of k. So this is the property. So we have to make use as per the given numerical. Now start doing it and start solving the numerical. So what do I get now? I'm actually finding DFT of x of n plus 1 with the base 4 equal to what? W4 to the power k into m. So k remains as it is. So now I need to find m. What is m? So here minus sign, it is not there. So it must be written as minus of minus 1. Therefore m must be minus 1. Are we getting it? M must be minus 1. So I'll write it as minus k. W4 to the power minus k x of k. So this is what the expression for x of k, x2 of k. Now we got. Therefore, I'll write x2 of k is equal to w4 to the power minus k x of k. Is that okay? So now I can simplify it further. Once we get this, so just substitute for w4. What is w4? It is e to the power minus j 2 pi divided by 4 into minus k x of k. So simplifying it further again, what do I get? It is e to the power minus of minus, it becomes plus j, uh, 2 ones are 2 twos are. So I'll get e to the power j pi by 2 x of k. So what is e to the power j pi by 2? Using Euler's rule, I can write it as cos pi by 2 plus j sin pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1, into j it becomes j. And there is a k term here. I can write it as j to the power k x of k. Are we getting it? So this is how I get the final expression for x2 of k. So once we get this, I can put the value for k equal to 0 to 3. I can find the different sequences. Therefore, for k equal to 0, first let put k equal to 0, I would get x2 of 0. So just put in the expression j to the power 0 x of 0, j to the power 0 is 1, x of 0, what is x of 0? It is been given in the numerical. Here it is 1. So 1 into 1, I will get it as 1. Is that okay? So next, similarly, put k equal to 1 so that I would get x2 of 1 now. So what must be x2 of 1? Consider this expression. In that expression, I'll put k equal to 1, j to the power 1, x of 1. J to the power 1 is j. What is x of 1? Just go up and check. X of 1 is nothing but j. So I will get it as j into j. So what is j into j? It is j square, and j square is minus 1. Is that okay? The first sample was 1, second sample I'm going to get it as minus 1. Similarly, put k equal to 2. If I put k equal to 2, I'm going to get it as x2 of 2, which is equal to j to the power 2 x of 2. J to the power 2 is nothing but j square, which is nothing but minus 1. What is x of 2? X of 2, just go up and check, it is 1 into 1. So it is, I'm going to get it as minus 1 again. Is that okay? Similarly, the last term, I'll get it by placing k equal to 3. If I put that, I will get x2 of 3, which is equal to j to the power 3 x of 3. J to the power 3, I can write as j square into j. J square is minus 1 into j, it is minus j. What must be x of 3? X of 3 is nothing but minus j. So I'll get minus j into minus j is equal to j square, which is equal to minus 1. So ultimately I'll combine everything and I would get the expression for x2 of k. I'll get the different samples as 1, the first sample, second sample is -1, third is -1, and fourth is also -1. So this is how I get the expression, the value answer for x2 of k. Is that okay? So we are left with the last part, that is C. I would write it as to find. So let me go up and check what was the question. The question was x3 of n is equal to x of 4 minus n. I need to find DFT of that. To find DFT of x3 of n is equal to x of 4 minus n. So how do I find DFT of that? So I'll write that DFT of x of n minus n is equal to what? It is nothing but DFT of x of minus n. So this is nothing but making use of circularly folding property. It is circular folding property. Is that okay? What is the DFT of such a sequence? Is equal to, so I'll write it, is equal to x of k minus n, or also equal to x of minus k. So this is what I get. Is that okay? So now we already have x of k. So I'll write that. There we know that. I'll write that. We know that x of k is equal to. It has been given in the numerical, which is 1j 1 minus j. So I'll write that 1j 1 minus j. So this is x of k. So what I want now? I want x of minus k. So that is nothing but x3 of k. Therefore, x3 of k is equal to, is nothing but x of minus k is equal to what? What do I get? So what is x of minus k? This is time shifted frequency. It is a shifted sequence. To be precise, it is reflected version. Minus k indicates it is a reflected version or the mirror image of this sequence. So how do I find that? Finding these things, we already know it. So let me say it again. So I'll just draw a circle, and in that circle I indicate the different points. The first point would be, this is 1, this is j, and this is my 1 again, and this would be minus j. So if I read it this way, I would get x of k. So if I read it this way, it is anti-clockwise, I'm going to get x of minus k. This is what I'm looking for. So x of minus k must be, this is 1 minus j, 1 and j. So this is how I get the expression for x of minus k, which is nothing but x3 of k. So, and this is the answer, final answer. I guess everyone has understood the numerical. If there are any doubts, please watch the video again. Or if there are still many more doubts, please let me know them in the comment section. I will definitely answer them. Meanwhile, don't forget to subscribe to the channel EnggClasses for more videos on digital signal processing. Thanks for watching.